Okay, today we're going to be working on Chapter 10, Lesson 5, which is surface area of pyramids and cones. You'll find that this lesson is going to be very similar to the lesson on surface area for cylinders and prisms. So let's take a look at some of the definitions here. We'll skip over that warm-up. So first of all, when finding the lateral area and the surface area of prisms, a couple things we need to know. First of all, the vertex of a pyramid is the point opposite the base of the pyramid. The base of a regular pyramid is always going to be a regular polygon, and the lateral faces are all congruent isosceles triangles. This is, again, for a regular pyramid. The slant height of a regular pyramid is the distance from the vertex to the midpoint of an edge of the base. So for example, if we look here, if I zoom in, it's a little bit hard to see, but not too bad. From the vertex to the midpoint of the edge of the base, that blue line right there is the slant height. Okay? And then finally, very similar to when we were talking about cylinders and prisms, the altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base. So in terms of a regular pyramid, that altitude is going to be right down the middle from the vertex to the center of that regular polygon base below. In a non-regular pyramid, that altitude may fall completely outside of the pyramid altogether. So if I was drawing it on this, it would kind of come down out here, and as long as it met on this plane in a 90-degree angle, that would make it an altitude. All right, so let's go through the lateral area and surface area of pyramids. Let's go through these formulas here. So the lateral area of a regular pyramid with perimeter P and slant height we'll call that L, cursive L, is capital L for lateral area equal to 1/2 of the perimeter times the slant height. Okay, then moving on, the surface area of a regular pyramid with lateral area and base area is going to be the surface area is equal to the lateral area plus the area of the base. Now let's translate that to what we learned about lateral area, that's going to mean that the surface area is going to be equal to 1/2 the perimeter of the base times the slant height plus the area of the base. So that is going to be the formula that we need to find the surface area for a regular prism. So if we look at the first example, it says find the lateral area and the surface area for a prism that has a base edge of 14 centimeters and a slant height of 25 centimeters. So the first thing we'll do is we'll find lateral area. The lateral area is going to be equal to, again, according to my formula up here, lateral area is equal to 1/2 times the perimeter. Well, the perimeter is it's a square pyramid, and each edge is 14. So that would be 14 times 4, which is the same as 7 times 8, or 56. And the slant height is 25. For a grand total of 700 centimeters squared for my lateral area. And then for the surface area, it's going to just be the lateral area, 700, plus the area of the base, which in this case is 14 times 14, 196. So we got 700 plus 196 equals 896 centimeters squared. And that's lateral area and surface area of a pyramid. Moving on to a right cone. Here we have the vertex. Well, the vertex is pretty much the same thing as a pyramid. It's going to be the point opposite of the base. The axis of the cone is, and I think we have to add to this a little bit, is the segment with endpoints at the center of the base and, I thought there was something missing here, and the vertex. So the endpoints are the center of the base and the vertex. And then you have a difference between a right cone in the right cone, the axis is going to be perpendicular to the base. In an oblique cone, it's not going to be perpendicular. And you can see that difference down here. We have a right cone. Here it's perpendicular. The axis is perpendicular. And in an oblique cone, it is clearly not perpendicular. Then we have the slant height. Slant height is very similar to that of a pyramid. It's the distance from the vertex of the right cone to a point on the edge. Any point on the edge. And then the altitude, again, is the perpendicular segment from the vertex of a cone to the plane of the base. So in the case of a right cone, your axis is going to be your altitude. In the case of an oblique cone, that will not be the case. In this case, we would have an altitude that looks something like this, as long as it intersects the plane of the base in a right angle. That'll be the altitude. So now moving on to the formulas for a cone, the surface area and lateral area of a cone. The formulas are as followed. The lateral area is going to be equal to the radius pi. It's going to be equal to pi times the radius of the base times the slant height. That's going to be your lateral area. And the surface area is going to be, again, like we did before, it's going to be the lateral area plus the area of the base. Well, in this case, that translates to being the, let me move this up a little bit. Surface area is going to be equal to pi times the radius times the lateral height, which is the lateral area right here, plus area of the base. And because it's a cone, the area of the base is always going to be a circle, so that's always going to be pi r squared. So if we're looking at example 3, if we want to find the lateral area is going to be equal to pi times the radius times the slant height, which would be 45 pi centimeters squared, and the surface area is going to be that same 45 pi plus the area of the base. And in this case, the radius is 9, so it would be pi times 9 squared. So we would have 45 pi plus 81 pi for a total of 126 pi centimeters squared for our surface area. Okay, that's it. Just remembering that the base of all cones is going to be a circle, and remembering that the surface area for either cones or pyramids is always just the lateral area plus the area of the base. And that is finding surface area and lateral area for cones and for pyramids. Thank you.